Assalamualaikum and good day to all members of panel. My name is Shuhada Binti Ali and this is my video presentation for PSM1. My supervisor is Dr. Zulina Binti Shamsuddin and title of my investigation is the effect of eco-waste failure loading on tribology behavior of ABS polymer composite for loading application. Introduction, I would like to start with quotation from Robert 1997 that said, all the variables associated with rolling, none is more important than friction in the roll by. Friction in rolling, as in many other mechanical processes, can be a best friend or a mortal enemy, and its control within an optimal range for each process is essential. When Robert wrote about friction, it is further appropriate and even necessary to replace that term with tribology. Tribology is an important field which is involved the design of components having static and dynamic contacts that meet specified performance and reliability requirements according to Gabas and Motica 2019. So one type of plastic that commonly used in industry is acrylonitrile butadiene citrine, or known as ABS. ABS is among the largest volume engineering thermoplastic polymer. So the main objective is this research is to strengthen ABS using filler in order to enhance the material characteristic. The filler material chosen is recycled carbon fiber from trimming waste that may be recycled for use in reinforced material, and also to find suitable percentage of recycled carbon fiber that can mix with ABS by having the highest value of tensile test. The problem of this investigation is the effect of ABS polymer composite properties of the functionalized recycled carbon fiber. Net is polymer alone cannot meet the essential properties for applications. Hence, eco-material derived from waste such as carbon fiber as a filler are used to increase the mechanical performance of the product in comparison to wear attribute. And last problem statement is optimize the parameter to obtain the highest value of tensile test. The objective of this investigation is to study the effect of filler loading on strength properties of ABS polymer composite. Second, to evaluate the effect of parameter testing where properties of eco-waste or ABS polymer composite using pin on this. And to correlate the effect of eco-waste loading with waste strength properties on morphology using scanning electron microscope. And the scope of this study is focusing more on mechanical and tribological properties of ABS and recycled carbon fiber through single screw extrusion and hot press. The sample is composite with ABS and recycled carbon fiber. For the tensile test, will be conducted using the ASTM D2344 to measure the tensile strength. And the morphology or structure of ABS polymer composite will be analyzed under scanning electron microscopy. Next, we move to the literature review that I was used in this study. First, Jiang 2005 investigate the effect of strengthening ABS with calcium carbonate particle with micro and nano size. They conclude that the microcrystalline cellulose or ABS composite had a higher relative elastic modulus and lower relative tensile and impact strength when compared with ABS alone. Next, according to Binti 2012, that investigated the mechanical and tribological properties of ABS filled with graphite powder. It was observed that increasing the graphite content in the ABS matrix led to a drastic decrease in tensile strength, while it produced a good enhancement of the tribological properties and friction coefficient. This was possibly because the graphite powder is a solid lubricant. Colombo, Virginie, and Burman at 2012 was used both basalt fiber to strengthen the polymer matrix. They need to study the effect of basalt fiber on the mechanical properties. The results show that high mechanical properties were achieved for both tensile and compressive behavior. Moreover, the failure modes were found to be tighter and more concise. Next, according to Abdel Halim, 2016, they investigate the strength of ABS using basalt fiber. They use an injection molding machine to manufacture the basalt fiber and also ABS composite with a varying percent of filler. And they conclude that both tensile strength and roll hardness improve with the increase of percent basalt fiber, while the impact strength is decreased. And Sudapan at 2015 have studied the effect of very microsizing oxide content in a matrix of ABS polymer on the mechanical and tribological properties. It was concluded that the tensile and fractural modulus and the hardness generally increase up to 15% before decrease again. They also report the enhancement of the wear and friction coefficient with the filler content. Next, we will move to the material of ABS. ABS is an engineering thermoplastic which consists of an amorphous with very good mechanical properties. And also ABS is easy to fabricate and it's lightweight. ABS has a good balance of properties, toughness, strength, and high quality surface. So the advantage of ABS is that this material combines the strength and rigidity of the acrylonitrile and styrene polymers with the toughness of the polybutene rubber. Generally, ABS would have useful characteristics within a temperature range from -20 to 80 degrees Celsius. According to Gautam Vinar 2018. For carbon fiber or recycled carbon fiber, based on Morton, shown that high modulus, high strength carbon fiber may generate reinforced polymer composite with strength and stiffness much higher than glass fiber composite. And carbon fiber are the most popular candidate for the development of structural and functional reinforced polymer composite because of their high surface to volume ratio, outstanding thermal, mechanical, and electrical properties, and also good dispersion in polymery. And the demand for the industry for high-grade carbon fiber is expensive and valuable due to economical and effectively to recycle and also to recover according to Part 2009. And as you can see, the figure shows the structure of recycled carbon fiber. Next, we move to the material and method in this slide. I will tell you about the process flow in this investigation. Begin with the raw material, ABS pellet and recycled carbon fiber. ABS pellet with density 1.04 gram per centimeter cube with net flow index of 21 gram per 10 minutes. And the filler content of recycled carbon is 5, 10, and 15%. The ABS pellet will go through drying process using never term drying oven at 120 degrees Celsius for 6 hours to remove the moisture. And the specimen will fabricate using single screw extrusion with diameter of 18 mm, screw speed of 60 rpm, and pressure 34 megapascal at temperature 275 degrees Celsius, followed by hot press. And the specimen will be tested with U-10 machine to get the tensile strength result. And using the scanning electron microscope for mechanical properties analysis. And finally, I will choose the best result to select, and we will continue with conclusion and discussion. And then the investigation will be end. And the last slide will show you the machine or equipment used for specimen fabrication. Firstly, single screw extruder, where the polymer material is melted and extruded through a die to employ for the mixing recycle of carbon fiber with ABS pellet homogeneously. Second, the hot press, where the pelletized granules are placed in a rectangular mold and subjected to hot compression mold. Third, micro pin on this tribometer will be used to test the tribological. And last, scanning electron microscope used for analyze morphology or structure of ABS polymer composite. Thank you, that's all from me.